In this lesson, I want to talk about asynchronous programming, or we might call multi-threading. We're going to run pieces of code on separate timelines at the same time. This is really useful for running multiple tasks concurrently, in which we have two things happening together. We don't use asynchronous programming much in the types of programs that we've been writing in this course and the previous course. These are more commonly used in large programs with really lengthy processes, such as large databases, data warehousing and data analysis, deep learning, machine learning, Internet of Things, maybe some really complex games, even some animation. But I want you to be aware of this because you will see this in the code of others as you explore code or look at different C# videos. And also as we get into using NuGet packages, we're bringing in programs that another person has written and using the routines of those in our programs, you might encounter some asynchronous programming, and you need to be aware of how to use it. To date, we've done synchronous programming. We might have a method that we call, and when we call that method, our execution detours to that method and it works that method and to its completion and then returns back and continues the next statement in our calling method. Now, if that lengthy process is long, it may appear that our program is hung. With asynchronous programming, we've got an asynchronous method in which we call that method and it immediately returns control back to the next statement while it continues to do its thing. And there's a few requirements for doing this. We have to have an async modifier in our method. And the method should end with the name async. It doesn't have to, but that's tradition. It must include a return type of either void, task, or task of type T. So task of type T, of course, is a generic, and that T can be an integer, it can be a string, it can even be a list or an array, and it must have at least one await command or await expression. Well, what is that? Typically, it's another task. That await expression must, however, contain an isCompleted variable, Boolean variable, and a method called getResult and a method called onCompleted. Oftentimes, in coding an asynchronous method, I may not have a task like that. So what I'll include is simply a delay. And you can await the task.delay and tell it the number of milliseconds. So 100 would be 1/10 of a second. If you do 10s, it's going to be 1/100th of a second. Doesn't really slow things down much, but allows us to use an asynchronous method. A couple things to be aware of is we can't pass arguments by reference, though we can pass them by value, and we can't directly access controls on the main thread. I'll show you in a minute how to get around that. We can create an asynchronous method and not have it run concurrently. I think the biggest advantage of using asynchronous methods is where we want to have multiple processes happening at once. And while the creation of an async method doesn't guarantee that happening, we can make that happen using Task.Run. So that'll run it in its own thread, its own timeline. And there we simply have a task return type with a variable, and it's going to equal Task.Run and then the name of our method. When that method is done, it returns a result to myTask. And we can access that result by using myTask.result, or whatever the name of our task is. That unwraps the value. Now notice we have for our return method, it's task of type T, and we return the T value, so we're returning an integer in the expression here, but I have to unwrap that. So the task is a wrapper that then has to be unwrapped. And we can use .result to unwrap that and get back to that very basic data type, in this case, our integer. A problem arises when we have a thread that is separate from the main form thread in that we cannot access the controls on the main form in WinForms. The way around that, though, is we can invoke an action that will update the controls. And the way we would do that is we can check to see if that control requires an invocation, which in most cases it will. And so here I have if LBL progress, which would be my label, invoke required. So if that's true, that's a Boolean expression, then LBL progress.invoke, I'm going to invoke a new action, and that action is a lambda expression. So a lambda expression is simply a method that doesn't have a name. But you'll see there's parentheses here, and that means that this is a method, and we could actually put arguments inside those parentheses. I don't need to here. All I'm going to do is just say the parentheses And then we have equals greater than, that's the lambda operator. And we'll talk about lambda expressions in a couple weeks. And then what I want to have it do. So the body of that method. The body of that method here is simply LBL progress, that's my label, .text equals done. Then I'm also going to refresh the screen. So here I just say invoke, this is going to go back to form 1, new action, this.refresh. Because this code is residing in the class on the main form. Now, if I don't need to do an invocation, then I just simply update the label and refresh the screen. That's the else fork. Let's take a look at an example. My first example here is our old friend, the triangle calculator, in which we're giving sides A and B, and we want to calculate the hypotenuse. So we've done this before synchronously. Let's look how we can do this asynchronously. And I have a text box, txt side A, another one txt side B, and txt side C, and then my calculate button named btn calculate. Let's take a look at that code. So my btn calculate, I'm going to get side A and side B and parse those out as double values. And then I have a task of type double that I call hypotenuse, and I'm going to call Task.Run. Now I have here what we call a lambda expression. We'll talk about lambda expressions more next week, but it simply is a method that is not named. So I have a set of empty parentheses which tells me this is a method. There's no parameters to this method. Instead, we're calling our getHypotenuse async method and passing it side A and side B. Now again, these are being passed by values. That's not a problem. This little equals greater than symbol that we call a lambda operator. So it's going to return a task called back into my value of hypotenuse, and it's going to contain a double value. txt side C then .text equals, I'm going to take that hypotenuse and get the result. That's going to unwrap it. That's a double value. I'm going to convert it to a string with 1 decimal place. And here's my get hypotenuse. Notice it's an async method, and I named it get hypotenuse async. I'm passing it double A and double B. The return type is task of type double. So double C equals the square root of A squared plus B squared. And there's my await. I'm going to wait just 1/100th of a second, and I'm going to return the value of C. That return value is a double, and it's being wrapped by the task and coming into hypotenuse, which is expecting a task of type double. Let's watch this run. Now, doing it this way doesn't bias anything. In fact, there's a little more work in this case. So again, that's why we haven't used asynchronous programming in what we've done, because for the type of programs we're doing, it's just not really pertinent. But again, I want you to be aware of it. So we'll see that this works exactly as it did with our synchronous programming, except we're calling that calculation of the hypotenuse method asynchronously. Let's look at how this can be of value. I created another C# application that hopefully will show you the value of using asynchronous program for lengthy processes. Let me first run this so you can see what it does. So I have 2 demos. They each do the same thing, but one is synchronous and one is asynchronous. One is going to create 1,000 dice rolls. We'll see die 1 plus die 2 equals the total. We'll get 1,000 of those. The other one will create the alphabet randomly jumbled. So all 26 letters, but not in the order of A through Z. And we'll create 500 of those. Let me first run this synchronously, and I created some benchmarks in here so we can see how long it takes. So here's the synchronous demo. And you can see that the first task is running. It's creating my 1,000 dice rolls, putting those into this list box. Once that is completed, then it's going to do the alphabet jumble and give me 500 of those. And we can see it took a total of, in this case, just about 23 seconds. Task 1, the dice rolls, took about 15, and the alphabet jumble took a little over 8 seconds. So combined, they're about 23 seconds total. Now let me do this asynchronously. And you can see they're both happening at the same time. That's the value of using concurrent asynchronous methods using that Task.Run. So task 1 took about the same time, just about 14 seconds. Task 2 Took a little bit longer, 14 seconds. Part of that is the refreshing of the screen. But notice the total here. The total was 13.6. Just a little bit longer than the longest task there, which was task 1. And that little bit slight extra time of the milliseconds is the benchmarking that's taking place. Let's take a look at how this was done and the difference in the code between these two. So just a quick overview of my interface. I've got a list called LST Task.One sync, LST Task.2 sync, a button BTN synchronous demo, and a LST report sync. For this asynchronous demo, kind of the same thing, LST Task.One async, LST Task.2 async, those are both list boxes, of course. My button, BTN asynchronous demo, and my report of LST report async. Let's take a look at the synchronous code first. So I created a random number generator. I created a stopwatch called stopwatch total. So it's a new stopwatch. The stopwatch allows us to start and stop the stopwatch and get the elapsed time in between. It's a great way for doing some quick benchmarking. And then I have another double value called time 1 and one called time 2. These are going to be stopwatches internally in our processes, and I'm going to pass the values of those to time 1 and time 2. Remember, we saw the time for task 1 and the time for task 2. We're passing those values internally into these two variables, and then the stopwatch total is our overall time for the entire process to run. Okay, so here's our synchronous demo. I created a task 1 method. Doesn't return anything. It's going to perform the 1,000 dice rolls. Nothing really new here. We created another stopwatch called stopwatch 1. This is going to be our start time. We're going to start it. Got two variables, die 1 and die 2. Those are going to be for our 2 dice that are rolled randomly. And then a for loop that's going to roll those dice 1,000 times. We're going to randomly get the first one, the second one, and then I'm going to add to my LST task 1 sync items. I'm going to insert at the top. So you always see the top one, always see the most recent number at the very top. It's easy to track the progress. So I'm going to insert at element 0 the value of our loop, so where it's at, 0 through 1,000, and then dice 1 plus dice 2 equals in the total. And I'm going to refresh the screen. If I don't refresh the screen, we won't see anything happening. So refreshing the screen does take some added time. And that's where these two values can be off a little bit. But the thing I wanted you to notice was with the asynchronous, the total time is not the task 1 and task 2 combined. It's whatever task was the longest. So it's a little bit comparing apples to oranges here into how we refresh the screen, because I can't refresh the screen directly asynchronously, but I'll show you how I do it another way. And that causes these times maybe a little bit longer. I'm going to stop my stopwatch. I'm going to get the elapsed time. And I'm going to set time 1 equal to that elapsed time divided by 1,000. I do 1,000.0 because I want a double value. Elapsed time is an integer. And that's going to give me the number of seconds with 3 decimal places. My task 2, we're setting the jumbles of the alphabet 500 times. I'm going to start another stopwatch. Stopwatch 2. We're going to start it. Again, a loop going through 500 times. I'm going to create a string. And then within that string, then within that loop, I'm going to create another for loop that's going to go from 0 to 25, or 1 through 26. This is going to be all of our letters. And we're going to use each letter once, and as we use it, we're going to get rid of it. So I have my string of letters. While my string.length is less than 26, we're going to do this 26 times. And I just realized I didn't need to put this in a loop going 26 times, since I'm already doing that here. But that's okay. We're actually creating 26 of these at once, which forces us to take a little bit longer, which really enhances our demonstration a little bit. So I could have done away with this for loop and just put this inside the loop, the string and this inner while loop. So int idx equals rnd next letters.length. I'm going to get a number for how many letters are still remaining. I'm going to get an index number, and I'm going to pull the substring from that index, just one character, and I'm going to remove that character from our letters string. That'll use each letter once in 26 times. Then I'm going to insert that into our list box, and again I'm going to refresh the screen. Stop my stopwatch and figure out the elapsed time in seconds. Now here's my button. I'm going to reset stopwatch total because we're going to use that same variable again, or the same object again in between synchronous and asynchronous. I'm going to start it. I'm going to call task 1, then I'm going to call task 2, then I'm going to stop my stopwatch, get the elapsed time, and create my report. That's the synchronous methodology. Let's look at the asynchronous. So here I have task 1 async. Note it's an asynchronous method. It's returning a task. Task does not contain a return type. It's just an empty task. Could have used void here as well. Stopwatch 1. I'm going to start it. I'm going to create a list of string type roles. And then I'm going to create my 2 variables for the dice, die 1, die 2. Go through this 1,000 times. Again, we're going to randomly generate those 2 die. And here's where I'm getting around that fact we can't access a control on the main thread, which is our form 1. If I just try to do lst task1 async.items.add, I'll get an error. So instead what I do is if lst task1 async.invoke required, in other words, I can't access it unless I invoke it. And we're going to use an invoke method. This is just a way of accessing that control on form 1. I'm going to call a new action. Again, this is another lambda expression. And I'm going to call lst task async.items.insert. And we're going to insert the number and our 2 dice in the total, just as we did before. But we're doing that within our conditional here. If I don't need to invoke it, then I can just call that. Now, it's not going to be the case here, but it's just there. I could actually leave that off. It'll still run just fine. I don't refresh the screen here because I'm going to refresh the screen with the second action, and I found that it takes just a little bit longer maybe, and so it'll just simply refresh both of them at the same time since they're going to be happening simultaneously. Stopwatch 1, I'm going to stop, get my elapsed time. I'm going to set time 1 to the elapsed time. So that is a global, public global variable, so I can access it from outside of the main thread. How to make sure you make that public. You just go back up here to the top and you can see those are public double values. If they're private, I would get an error. Here then is my task 2 async. Again, it's an async method. It's going to return a task. I've got my stopwatch 2. I'm going to start it. I've got a loop going 500 times. We're going to create a null string called myString. We're going to do this 500 times. Now again, I don't need this loop here. Those 3 lines I could get rid of. These 2 and that one. Because actually what I'm creating is each string I'm creating 26 times rather than just once. It'll actually speed things up. But again, for the demonstration purposes, since we went something a bit longer tasks, this actually works out well. I'm going to create my string using each letter once, just as we did before. Now here's what I'm going to invoke. Accessing the list box for lst task2 async. If I require to do that, which I will be, I'm going to call a new action as a lambda expression and set the items of lst task async, lst task2 async. And then I'm also going to invoke here another action which is going to refresh that screen. So we'll see it happening pretty much in real time. If I don't need to invoke it, this is just the normal way I would process this. Again, this else fork probably really isn't needed here. I'm going to stop my stopwatch, get the elapsed time, set my time to the elapsed time divided by 1,000.0, so I get a double expression, and I'm going to await my task for 100 milliseconds. Again, I have to have an await if I have an async. And I don't have any awaitable task in here, so I just do a slight delay. You can ignore this expression here. That was, again, something else I was trying. Here, though, is my button. So I'm going to clear LST report async items. I'm going to reset the stopwatch total, start it. Now here's where I'm calling these two, task 1 and task 2, concurrently. var t1 equals task.Run, and I'm going to call as a lambda expression my task1 async method. Now I use var t1 here. I could have used task t1. That would work just as well since it's returning a task. But var t1, but in var t2, allows us to not be specific and to pretty much handle anything. So those are valuable. var t2 is going to equal task.run, and we're going to call the task2 async. Now again, since these are being called asynchronously, this one will start, and then immediately this one will start. Does not wait for task1 async to finish running. We're going to await the Task.WhenAll. So I'm going to wait for both of those to finish. So I have an await here in my button event handler. So I made it an async, and it doesn't return anything, so I left it as void. But I wanted this await task, and this WhenAll says, okay, I'm going to stop here and wait for these two to finish, both T1 and T2. Then I'm going to stop my stopwatch. So we're getting that slightly extra milliseconds for our total task. I'm going to get the elapsed time, and then I'm going to display those results for task 1, task 2 in the total. Again, let me just run this one more time. Here's the synchronous demo. So there's task 1 running. You can see it's not doing anything task 2 because we're not seeing our scroll bar yet. We're not seeing any values in there either. There's task 2. So it finished task 1. It's now working on task 2. And so task 1, 15 seconds this time, 8.5, total still running 23 seconds. Let's do the asynchronous. And so then the asynchronous, task 1 took about 10, almost 11 seconds. Task 2 took almost the same time, and my total, though, was just over 11 seconds, just slightly more than whatever task was the most. So you can see that in a really lengthy process, by reading in a huge amount of data, we can cut that time, especially reading maybe multiple data files. We can cut that time considerably by doing them at the same time. That's asynchronous programming in a nutshell. There's a lot more to it, but this at least lets you know what asynchronous programming entails. If you just jumped into this video, you can see all the videos from the C# Xamarin Programming Cohort playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.